Here we see the Z-Table website that's been posted in the class, and you can use this as a Z-Table chart to help you calculate your Z-scores by hand. If you notice here, you can also just download it as a PDF, or you can use your calculator with the instructions that are given in the book. I actually prefer to just do it by hand. I feel like I know better what's going on. And even if you use the calculator, make sure you show your work on the homework and you also talk about the formula so that I at least know that you are able to do this kind of scoring. So let's look at the Z-scores and understand at least just what the table is telling us. So first, actually, let's look at this normal curve up here at the top. This is basically the headline for this particular part of the chart. It's telling you that this part of the chart is for values that are lower than the mean, median, mode here on the normal curve. And so what we see here is that these Z-scores are all negative. Now, why would that be? Well, if you look back at the Z-score formula, and you'll notice that the numerator of the formula has the value that you're looking at, and then you subtract the mean. So if all of these scores are from points on the curve that are below the mean, then you're going to end up with a negative value for the Z-score. So if you do end up with a negative value, that's perfectly fine. It just means you're to the left of the curve. And the way you read this chart is, let's say you end up with a Z-score of negative 2.73, just for example, 2.73, negative 2.73. So you come over here to negative 2.7, and because it's 2.73, you would look over here in this column. So this is the probability that's associated with the value of negative 2.73. That would be 0.0032. Now, what does that value actually mean? Well, let's go back up to looking at this example here. If you have a Z-score of negative 2.73, 0.0032 is the shaded area. That's the amount of the curve to the left of the point that gave you that Z-score. And when you think about it as percentiles, you would multiply that by 100. So really it's less than the first percentile. It's 0.32% of the curve is to the left of whatever point gave you that negative 2.73 Z-score. So that would be a value that's very far away from the mean. Now let's go down here and you'll see the second part of the table. And this part of the table is all values that are to the right of the mean. And it still gives you the probability of the shaded area here. So if you notice up here, this table ends with negative 0.00 being exactly at 0.5. That's the 50th percentile. That is the mean, median, and mode. And that is where this one picks up with positive 0. Remember that 0 is actually both negative and positive. And you can see here that these values start with 0.5 and go higher. So pretty quickly, it gets all the way to points that look like 0.9394, right? So that means 93% of the data has a Z-score, is less than the point on your curve where the Z-score value is 1.55. So you can see the data there goes down pretty rapidly. And that's because most of the data is concentrated plus or minus 1 standard deviation away from the mean. So when you start getting above 1 here and below negative 1 here, then the values really go down. There's just not a lot of probability in that part of the curve. Those are the potential outliers. Those are the ones that might be skewing the data. And you can see here it goes all the way up to 0.9998. And it is possible to get a Z-score higher than 3.49, which gives you that highest point here on the table. And if you do, you would just say, well, the probability is greater than 0.9998. You know, it's almost 1. Now, why would the probability get to nearly 1? Well, remember, under the entirety of the whole curve is the whole range. So all of this shaded area under this curve does add up. It is 1, you know, all the way down here. The probability of all of this equals 1. So what you're trying to find is the probability of each point, each value within the data set.